Namaste, my friend, and welcome back to NEET Chemistry with Typical Monk. This is class 2, and today we go somewhere no eye can follow, inside the atom itself. Now sit with this for a moment. Nobody has ever seen an atom. It is far too small for any microscope, and yet we can tell you exactly where its center sits, and we can read the colors of light it gives off like a fingerprint. When David first heard this, he asked the honest question, if we cannot see it, how do we know any of it? That is the whole adventure of today. We learned the inside of the atom entirely from the outside, by bouncing particles off it and by studying the light it glows with. So take a slow breath. Let us step inside, one idea at a time. So what will you carry home from today's class? First, 3 models of the atom, Thomson, then Rutherford, then Bohr. And, just as important, why each one had to be replaced by the next. Second, Bohr's energy levels, the beautiful little formula that says the energy of a hydrogen electron is minus 13.6 over n squared in electron volts. Third, the hydrogen spectrum, the Lyman, Balmer, and Paschen series, and the Rydberg formula that ties them together. Fourth, the modern picture, the photoelectric effect, the dual nature of light and matter, the Broglie's waves, and Heisenberg's uncertainty. And fifth, the NEET drills, assertion and reason, match the column, and the numericals, so everything you learned today you can also score with. Ready? One idea at a time. Let us walk through the atom story, model by model. First came Thomson's model, often called the plum pudding. He pictured the atom as a soft sphere of positive charge, with tiny electrons dotted through it like raisins in a pudding. It felt reasonable, but it was about to be tested. Then Rutherford fired a beam of alpha particles at a thin gold foil. Most sailed straight through, but a few bounced sharply back as if they had struck something tiny and hard. Sarah said it was like firing bullets at tissue paper and having one come back at you. From that, Rutherford concluded the atom has a tiny, dense, positive nucleus at its center, with the electrons far outside. The pudding was gone. But Rutherford had a problem. A moving electron should spiral into the nucleus and the atom should collapse. So Bohr fixed it. He said electrons move only in certain allowed orbits, each with a definite energy, and while an electron stays in its orbit, it does not radiate at all. Fixed orbits, fixed energies. And yet even Bohr has a limit. His model works beautifully for hydrogen and other one-electron systems, but it fails for atoms with many electrons because it never accounted for the electrons pushing on one another. Every model was a step, and every step was later corrected. Look at this ladder carefully, because it is the map for every spectrum question in this chapter. Each rung is an allowed orbit, and the higher the rung, the higher the energy. First, each orbit has one fixed energy. For hydrogen, the energy of level n is minus 13.6 over n squared in electron volts. So the first level sits at minus 13.6, the second at minus 3.4, the third at minus 1.5. Second, here is where light comes from. When an electron falls from a higher rung to a lower one, it gives out a photon, a packet of light whose energy is exactly the gap between the two rungs. Bigger fall, more energetic light. Third, the landing rung decides the family of light. Fall down onto the first level and you get the Lyman series in the ultraviolet. Fall onto the second level, the Balmer series, invisible light. Fall onto the third, the Paschen series, in the infrared. And fourth, notice every energy carries a minus sign. That minus is not a mistake. It means the electron is bound, trapped by the nucleus. Zero energy is the top of the ladder where the electron finally breaks free. Lisa remembers it this way: the deeper the well, the more negative and the harder to escape. Now let us turn those energy gaps into the actual colors we see. First, the two directions. When an electron drops to a lower level, the atom gives out light. That is emission. When it climbs to a higher level, the atom takes light in. That is absorption. Same ladder, opposite direction, and NEET loves to test whether you can tell them apart. Second, the Rydberg formula ties it all together. 1 over the wavelength equals the Rydberg constant times 1 over n1 squared minus 1 over n2 squared. Here n1 is the lower level and n2 is the higher one. Put the numbers in and out comes the exact wavelength of the line. Third, and this is the trick that saves you every time, the lower level, n1, names the series. If the electron lands on level 1, it is Lyman. On level 2, Balmer. On level 3, Paschen. And fourth, of all these families, only the Balmer series falls in the visible range, the light your eye can actually see. That is exactly why Balmer is the most examined series in the whole chapter. Time to solve a full NEET numerical together, slowly, the monk's way. A hydrogen electron falls from the third level to the second level. How much energy does it release? Step 1. Write down what is given. The electron falls from n equals 3 to n equals 2, and the energy of any level is minus 13.6 over n squared in electron volts. Never skip writing the given. Step 2. The formula. The energy released is the energy of the lower level minus the energy of the upper level. In symbols, delta E equals E2 minus E3. Step 3. Find each level. E2 is minus 13.6 over 4, which is minus 3.40 electron volts. E3 is minus 13.6 over 9, which is minus 1.51 electron volts. Step 4. Subtract carefully, watching the signs. Delta E equals minus 3.40 minus 1.51, which comes to minus 1.89 electron volts. Step 5. Read the answer. The energy released is about 1.89 electron volts. And notice where it lands. The electron fell onto the second level, so this is a Balmer line. Invisible red light. Given, formula, levels, subtract, answer, the same 5 steps solve every transition energy problem NEET can ask. Now the idea that broke classical physics wide open. First, light does not arrive as a smooth stream. It arrives in packets called photons, and each photon carries an energy equal to Planck's constant times its frequency. Second, shine light on a metal, and above a certain threshold frequency, a photon can knock an electron clean out of the surface. And here is the surprise that trapped everyone. Making the light brighter ejects more electrons, but not faster ones. Speed comes from frequency, never from brightness. John found that backwards at first, and so does most of the country in the exam. Third, so light behaves as both a wave and a particle. A wave when it spreads and interferes, a particle when it strikes and ejects. This is the dual nature of light. And fourth, de Broglie made the Bohr leap. If light can be a particle, then matter can be a wave. Every moving particle has a wavelength equal to Planck's constant divided by its mass times its velocity. Everythings have tiny wavelengths, which is why you never see a cricket ball ripple. Now sit up straight. These 5 lines are what NEET actually asks year after year. 1. The energy of a hydrogen level is minus 13.6 over n squared in electron volts. Memorize the first 3, minus 13.6, minus 3.4, minus 1.5. 2. A spectral series is named by the level the electron lands on. Lyman ends on 1, Balmer on 2, Paschen on 3. 3. The Balmer series is the visible one. This is the single most tested line in the chapter, so let it become second nature. 4. In the photoelectric effect, frequency decides whether electrons come out and how fast. Intensity decides only how many. Do not swap those two. 5. The Bohr model fails for multi-electron atoms, and it also violates Heisenberg's uncertainty by fixing both position and speed at once. Know its limits, not just its wins. Let us drill the NEET way. Remember the 4 options. Option A, both statements true and the reason explains the assertion. Option B, both true, but the reason does not explain the assertion. Option C, assertion true, reason false. Option D, assertion false, reason true. First one, assertion, the Bohr model fails for multi-electron atoms. Reason, it ignores the repulsion between electrons. Think like Sarah, check each statement alone, then check the link. Is the assertion true? Yes, Bohr breaks down beyond 1 electron. Is the reason true? Yes, it never included electron-electron repulsion. And does the reason explain the failure? Exactly, that missing repulsion is precisely why it fails. Both true. Reason explains option A. Second one, assertion, the Balmer series lies in the visible region. Reason, Balmer lines are the ones that end on the level n equals 2. Is the assertion true? Yes. Is the reason true? Yes. And does it explain? It does, because it is the fall onto the second level that gives just the right energy gaps to land in visible light. Both true. Reason explains option A again. Third one, assertion, the energy of the hydrogen electron is positive. Reason, a bound electron has less energy than a free one. Check the reason first. Yes, a bound electron sits lower than a free one. That is true. Now the assertion, the energy is minus 13.6 for the ground state, so it is negative, not positive. The assertion is false, the reason is true. Option D. A quick match now. Say each answer aloud before I reveal it. The Lyman series. It ends on the first level, and its light is ultraviolet. The Balmer series. It ends on the second level, and its light is visible. This is the one to never forget. The Paschen series. It ends on the third level, and its light is infrared. And the ground state energy of hydrogen, minus 13.6 electron volts, the very bottom of the ladder. If all four came to you before the reveal, the energy ladder is becoming yours. Here's a favorite new NEET format. I will read some statements. You silently count how many are correct. Statement 1. The Balmer series lies in the visible region. Hold your verdict. Statement 2. In the photoelectric effect, brighter light ejects faster electrons. Think carefully before you answer this one. Statement 3. The Bohr model works for hydrogen and other one-electron species. Picture the ladder as you decide. As so, how many are correct? Two statements, the first and the third. Balmer truly is the visible series, and Bohr truly does work for any single electron system. But the second one falls. Brighter light gives more electrons, never faster ones. Speed comes from frequency alone. That reversal is the trap. And now it will not catch you. Now let me save you some marks. 2 myths that trap thousands of students every year. Myth 1. When an electron jumps up to a higher level, the atom gives out light. It sounds active, energetic, so surely it glows. No? David believed this for months. But here is the truth. Jumping up absorbs energy. The atom takes light in. It is the fall back down that emits light. Up is absorption, down is emission. Keep that arrow straight, and half the spectrum questions solve themselves. Myth 2. Brighter light knocks electrons out with more energy. More light, more punch. It feels obvious. The truth, brightness, only changes how many electrons come out. Their energy is set entirely by the frequency of the light. One dim blue lamp can eject faster electrons than a blazing red one. Frequency for speed, intensity for number. Do not let that pair cost you a mark. Time to test yourself. Rapid fire. Here is the rule. I ask, you answer in your head before the reveal. No pen, no paper, just the ladder you built today. Question 1. What is the energy of the ground state of hydrogen? Straight from the formula, with n equal to 1, minus 13.6 electron volts. Question 2. What is the energy of the second level? Minus 13.6 over 4. That is minus 3.4 electron volts. Question 3. Which level does the Balmer series end on? The second, Balmer always lands on level 2. Question 4. How much energy does it take to ionize hydrogen from its ground state? You must lift the electron from minus 13.6 all the way to 0, so 13.6 electron volts. And question 5. The thinker. How much energy is released when the electron falls from the third level to the second? From our worked example, about 1.89 electron volts, a Balmer line. If you fired all 5 back before the reveal, you have truly understood today's class. Let us gather the whole class in one slow breath. 3 models, Thomson's pudding, Rutherford's tiny nucleus, and Bohr's fixed orbits, each one a repair of the last. each hydrogen level carries the energy minus 13.6 over n squared in electron volts, and that minus sign means the electron is bound. Falling electrons emit photons, and the families of light are Lyman, Balmer, and Paschen, with Balmer the visible one. The Rydberg formula links the two levels to the wavelength, and the lower level always names the series. The photoelectric effect and the Broglie reveal the dual nature of light and matter, and the Bohr model quietly fades for multi-electron atoms. And next class, we go deeper still into atomic orbitals and electronic configuration, the quantum numbers and the shapes of the s, p, and d orbitals. Do not miss it. And so, my friend, we have stepped inside the atom. It may have felt like a crowd of names and models, but hold on to the thread. We learned the inside from the outside by scattering particles and by reading light. The tiny nucleus, the ladder of energies, the glowing colors of hydrogen. None of it was ever seen, all of it was reason. Sarah, David, Lisa, and John all sat exactly where you sit now, a little unsure, and they built this picture one rung at a time. Be patient with yourself. Tonight, revise the energy ladder once, slowly, and say the 3 series aloud. One idea at a time, you will crack NEET. Of this, I am certain. If this class brought you clarity, subscribe to the channel so the next one finds you. Until then, keep going. I will see you among the orbitals.